So, welcome back. We're going to talk a little bit about the actual content of chapter one and make sure that we can get through all of this stuff. So, first thing I want to ask you before we really get into specific terms and things, I want to ask you this question. Why are you a psychology major? If you're in this class, you're a psychology major, and I want to know why. So, what is it about psychology that you love? So, for example, for me, I like a lot of things about psychology, but I specifically enjoy this social psychology of relationships. It's just fascinating to me how relationships work and why they're important, the emotions, the everything about them. So, you tell me, what is it about psychology that you are interested in? Great. Now, keep that in mind as we talk about what we're discussing. Because the reason why I ask that question is because we all want to know about these phenomena. We all want to know about these principles, relationships, or depression, or happiness, or motivation, or goals, or whatever the concept is in psychology. We all want to know about that. So the question is, how do you gain that knowledge? So what we're going to talk about today is some terms, sources of knowledge first, then some terms about population and samples. Then we're going to talk about experimentation and get to descriptive versus inferential statistics. So let's start at the very beginning here. And I want you to answer some questions, and then we'll tell you why in just a second. Do you plan to vote in the next election? All right, that's just an opinion. I don't really care what, well, I think you should vote, but it doesn't really matter what you say or don't say. Did you eat breakfast this morning? All right. The reason why I ask that is because those are what we call variables. Whether you're going to vote, that varies. Whether or not you ate breakfast, that varies. Okay? It's something that varies inside a person. And psychology is interested in all sorts of different variables. The things that you mentioned that you enjoy are things that include variables. So, for example, the quality of a relationship is a variable, right? It varies in different people. The question is, how do we get at that variable? How do we get at that concept that's important to us? Well, the scientific method is what we use in psychology. There is other ways of understanding the world besides the scientific method, but the scientific method is really based off of something called empiricism. Now, empiricism has to do with making something available to our senses, right? So something that you can see, hear, touch, smell, feel. That is what we mean by empirical. And the scientific method tries to make things tangible, empirical. So an example of this is when we talk about something called temperature, right? So you know what temperature means. The temperature in any given room or outside, that's the temperature. Now you can feel that with your hand, with your skin, you can feel a temperature, but it's not particularly precise in understanding what that is and being able to measure and understand the concept of temperature. So we use a thermometer in order to get at that, and we put a number to the amount of temperature. So what does that have to do with psychology and statistics? Well, what we're trying to do is we're trying to take whatever the variable happens to be. Let's say it's the quality of the relationship, and we're putting a number to the variable. So what you're trying to do is being able to put a number, make more tangible, more empirical the concept that you care about. That is what we're trying to do with statistics. It's all about trying to understand the concept more precisely. It's not about trying to torture people with math. It's about trying to understand the concept more precisely. That is why we're doing statistics. When we talk about statistics, we need to talk about the difference between a population versus a sample. So population is the whole population, but what do I mean by that? I mean it's the complete set of individuals that you want to study, right? It's everybody you want this research to apply to. That's the population, okay? It's the everybody that you care about, that you want this to apply to. Now, you probably are not going to be able to measure the whole population, so what we do is we take a sample. That's some people out of the population, and those are the ones that we actually measure. So if I wanted to understand about qualities of relationships, I would say I want to know about the qualities of relationships of everybody who is in the United States right now. but since I can't measure everybody, I'll take a sample. So let's say I take 100 people out of the population and measure the quality of the relationship. The 100 people that I took out of the population, that's the sample. The people in my study are my sample, the subset of the population. When we discuss populations, though, you should know a couple of different terms that are important. The first is the word census. When you measure everybody in a population, you have performed a census. Now, in the United States, we do a census every 10 years. It is required by the US Constitution to measure everyone. That is why it's called a census. If you don't measure everyone, then you've not performed a census. In order for it to be a census, you have to do everybody. Whenever we understand something about the population, the number that describes the population is called a parameter. So, the number calculated on population data that quantifies a characteristic of the population would be a parameter. So let's say we took a census about the quality of relationships in the entire United States. And let's say that the average quality of relationship was a 6. The average satisfaction of a relationship is 6 out of 10, right? That 6 out of 10 is a parameter because it describes the entire population. In statistics, we need to make a distinction because we are trying to understand population, but we're trying to do it using a sample. So, for example, this, in an example, let's go back an example with the elections. So in 2012, the election, the presidential election was going on, and Michigan would be the population. So let's say that I was an election official in the state of Michigan in 2012. And so if I measured everybody who voted, then that would be a parameter. So for example, I'm going to go to this Wikipedia page, and we'll show you a parameter. The Wikipedia page is about the presidential election in Michigan in 2012. And it'll tell you who voted for whom and how many. So now, one thing that's important is because we are talking about the voting that happened in Michigan, we're not now using the population as everybody in Michigan. That's not the population anymore. Instead, the population is going to be the people who voted in this election. So, for example, in this case, we see that Barack Obama in 2012 won 2,564,569 votes, whereas Mitt Romney got 2,115,256. Okay? So this idea that Barack Obama got 54.21%, that would be a parameter if the population is voters who voted in the presidential election in Michigan in 2012. Notice how that's different than everybody in Michigan in 2012. It's the people who voted in the presidential election in Michigan in 2012. The parameter would be 54.21%. That would be the parameter. A sample, conversely, is the subset of the is a subset of the population. It's a number that's calculated on sample data that quantifies a characteristic of the sample. A statistic is a number that is from a sample. A parameter is a number that's about a population. Let me say that again. A statistic is a number that quantifies something of the sample. A parameter is a number that quantifies something about the population. They are not the same thing. So, for example, let's say that I was in Michigan in 2012 and I was outside the polling place and I said, "Who did you vote for?" And I only asked 100 people. I asked, "Who did you vote for?" Let's say that 50 of the 100 people voted for Barack Obama and 50 voted for Mitt Romney. If that was the case, then 50-50, the 50%, would be a statistic. A statistic, because it represents the sample. The parameter would have been that 64% that we talked about before. There are different kinds of statistics. descriptive statistics and inferential statistics. A descriptive statistic describes the data from the sample. So for example, 50% voted for Barack Obama. That would be a descriptive statistic. An inferential statistic is one that we use to infer something about the population. So I take my sample, I measure the people in my sample, and my statistic is used to say, well, if this is going on in the sample, this is what I think is going on in the population. That would be an inferential statistic. We take something in the sample and we use it to infer what's going on in the population. So watch this video and it'll talk about how many people they use in a sample for something like a presidential election. So you'll notice in that particular video that they only used about 500 people to call the election for the state of Michigan. Now, 500 people, that's a lot fewer than the entire population. The entire population, you remember, is all the voters who voted. If you remember, we looked at that Wikipedia page, that's millions and millions of voters, and we're only going to take like 500 people. We meaning statisticians, so people who are statisticians understand that if you take your sample correctly, you can actually take a relatively small sample and be able to infer it for the whole population. Now think about how hard it would be to measure, to do a census on every single person who voted in the Michigan 2012 election. That would be really difficult. But if we do our statistics, we can do it with only about 500 people. Now, do we know that we're absolutely correct? No, there's always some error. We're always basing this off of some ideas of probability, and that's an important part of statistics. But we can take a sample and infer what's going on in the population, and generally do it pretty accurately. The whole point of this class is to understand variables in the population when we can't do an entire census. So what we're saying is, what we are trying to do in this class is take a sample and understand what's going on in the population based off of the sample. If I want to know the quality of relationships of people in the United States, I can't measure everyone in a census. Instead, I take a sample and I use the information from that sample to infer what's going on in the population. The entire point of this class is to take information from the sample and use it to understand the population. That is the whole point of this class. That's why you're doing this. What's a variable? A variable is anything that varies. That's it. So here's the definition that's a little bit longer. Any property or characteristic of some event, object, or person that may have different values at different times depending on conditions. It's something that varies. It's something that's different between people, right? So whether or not you wear glasses, that's a variable, right? Some people do, some people don't. It varies between people. How hungry I am right now, that's a variable because it varies inside of me, right? Sometimes I'm hungry and sometimes I'm not. How much sleep I got last night, it's a variable. How much I love my wife, it's a variable because it varies. How much I love my wife a lot. I don't want to say that it varies in a bad way, but you know, it varies, and certainly love varies between people. How much they love their spouse varies between people. What's important here is it's not a constant. I mean, it's not a constant variable. It varies, right? The amount varies. In psychology, what's important for us is that we operationalize these. Now, what are you talking about? So let's talk about this idea of relationship satisfaction. We cannot take the relationship satisfaction out of me, rip it out, and stick it on a scale and say, oh, you got exactly 2.8 ounces of relationship satisfaction. We can't do that. There's no way to do that. Does that mean I don't have any relationship satisfaction? Of course I do. I just can't get it out and stick it on a scale and say that it's blue. In psychology, we have to take these conceptual variables, these concepts that we're talking about, we have to operationalize them. We have to do something to make them concrete. For example, put a number to them. Now, there's two main kinds of operationalizations, and they are measurements and manipulation. So measurement's very simple to understand, okay? If anything you measure, is an operationalization. You've made it concrete. This is this conceptual variable, and you've made it concrete. So if you think about, how much I love my wife. So if you ask me, how much do you love your wife on a scale from 0 to 10? You are measuring love for my wife, and you're putting a number to it. And that number is a number between 0 and 10. Okay, that's a measurement. Manipulations are used in experiments. And what happens is we, the experimenters, change that variable in you. Now, it's another form of operationalization. We don't care as much about sticking numbers to it, but we care about being able to change it in an individual. So, for example, instead of measuring how much I love my wife, you could manipulate how much I love my wife. So let's say that you were the researcher and you gave me a love potion, and that made me more in love with my wife. That's a manipulation. In studies, we have to sample. And in order to sample, we get participants. The people we get to be in our sample, we call them participants. Sometimes, at least historically, we call them subjects. But we like to call them participants nowadays because we hope that they're actually participating and they're not just subjects. But participants are the people in the study, all right? The way that you sample sometimes matters depending on what's going on. So for example, you might hear something called a random sample. That means that every person in the whole population has an equal chance of being in your study. They're randomly chosen from the population. Now those are nice because they're representative. They represent the entire population. If you randomly take 500 people from the voters of the state of Michigan and you do it randomly, then that should represent the entire population of people who voted in Michigan. Those are ideal, but they're really rare, especially in psychology. We actually rarely do a random sample. Instead, we run experiments on people, and by being able to manipulate the variables, the actual sample is less important because we are trying to understand how the sample affects the outcome, right? Sorry, the independent variable, the thing that we're manipulating. We want to see how that varies the outcome. And that should be relatively standardized no matter what the sample happens to be. So what that means is a non-random sample can be representative specifically and especially if you're talking about an experiment instead of just measuring a bunch of different variables. So, types of studies. So the first thing you should understand is that generally we have observational studies, and these tend to be more measurement kind of studies. So a naturalistic observation is when you just go out there and people watch. Let's say that I think that males are more likely to play football than females. Okay, so I've got two variables there. Your sex, which is male or female in this particular case, right? And then the other variable that we're looking at is playing football, whether or not you're playing football. All right? So when I'm observing, I can just naturally go and I watch people and I see some people playing football and I say, all right, well, how many of them are male? Okay? I measure their maleness. I measure whether or not they're playing football. That would be like a naturalistic observation where I would get a correlational measurement. Parameter estimation. Now remember, a parameter is a number that represents the population. And so sometimes we are trying to measure things in order to understand and estimate the population. In any case, when we're doing these, generally we get a correlational study. You know it's a correlational study if you measure one variable and then measure another. So I measure your sex and then I measure whether or not you're playing football. Measure and measure. Measure one variable, measure another variable. That is a correlational study. Correlation does not equal causation. So just because more men tend to play football, that doesn't mean that being a man causes you to play football, right? Being male causes you to play football. It could be other things that are going on. In order to find whether or not something causes something, we do a true experiment. In a true experiment, we manipulate a variable and then measure a variable. The measure that you manipulate is called the independent variable. The variable that you measure would be the dependent variable. So if I wanted to do my your sex changes whether or not you play football, the independent variable would be your sex. And in order to manipulate that, I, the researcher, would have to randomly assign you to be either male or female. So what I would have to do, and this is not ethical, you shouldn't do this, but you'd have to take 100 people. Let's say you have a sample of 100 people. You randomly assign half of them to be male and half of them to be female, meaning that if they're not male already, you would have to go in and do a sex change to make them to be male, or conversely, make them to be female. And then you measure whether or not they're going to play football, right? Then you measure whether or not they're playing football. That's an experiment. An experiment you manipulate, meaning the researcher manipulates the independent variable and then measures the dependent variable. That does allow you to determine causation. And in psychology, we love experiments. We can't always do them on all the things that we care about. We love to do experiments. So let's do a practice on this and kind of see how this would work. So you've perhaps heard the stereotype that blondes have more fun. Well, in psychology, we can actually do things like test that. There's two ways we can do it. The big studies that you should know about are correlational studies and experiments. So the correlational study would look something like this. So I got this concept that I'm going to call hair color. Whoops, I don't know why that did that. Let's erase some things. All right. Hair color. And I think that hair color is going to affect the amount of fun you're going to have. Okay? Those are the concepts, the conceptual variables that we care about. In a correlational study, we would measure both of these variables. So what I would do is perhaps get an observation. Right? I would observe your hair color. Make sure that's a box. Okay, so in this case, the observation is the operationalization of hair color, meaning it's a measurement. I measured your hair color. And then I would measure how much fun you're having. Let's say on a scale from 0 to 10. Whoops. Okay. This would be a measurement of fun. Okay? And then what I'd say is, all right, I measured these people with their hair color, and then I measured how much fun those people were having, and it turned out that the people who were blonde had more fun. That would be a correlational study. That doesn't mean that being blonde causes you to have fun, though. It could be the opposite way. It could be that people who have more fun choose to dye their hair a certain color. It could be that there's other variables involved. We don't know in a correlational study. Conversely, what I could do is, whoops, I can run an experiment with this. So instead of going in there and measuring your hair color, I could manipulate your hair color. I could dye it blonde, or let's just do black. If I dye your hair blonde or black, then I, the researcher, am changing it. That's what's called a manipulation. And if I do that, then that would be able to tell me whether or not your hair color actually causes you to have fun. So I would dye your hair blonde or black, and then I would measure how much fun you're having on a scale from 0 to 10. That is an experiment. The operationalizations are dyeing your hair blonde or black, that's a manipulation, and the other operationalization is the measurement of fun. That's an experiment. One thing that you need to know, in this class, we do not say the word prove. Oh boy. We never, even if you run an experiment, you don't say, hey, we have proved that your hair color affects your fun. No, no, no. It's all based off ideas of probability. We never actually know for sure, for real, because we only took a sample. If we did a census, then we could know, right? But because we're using samples, we never, ever, ever say prove. So don't say that. Just don't say prove. Okay, so here is a knowledge check for you. I want to know if consuming fish oil really makes you smarter. How smart you are would be a dependent variable, right? The independent variable is if you ate or didn't eat fish oil. The independent variable is whether or not you eat fish oil. The dependent variable is how smart you are. Dependent is the outcome variable, right? The outcome that we want. Okay. The average IQ in my sample was 120. This is a statistic because it describes the sample. If this was describing if the average IQ in your population was 120, that would be a parameter. But because it's describing a sample, a number that describes a sample is a statistic. Datum is the singular form of data. So one number from one person would be a datum. That's the difference in those things. All right, everybody. Thanks.